In this example, we need to find the position function which is represented by x of t of a moving particle with the given acceleration represented by a of t. And we have also given the initial position x at 0 and also the initial velocity represented by v at 0. So we have given this acceleration function as a 20 sine of 2t, right? So that the acceleration function is everything given as a function of t. We have given the initial velocity as -5 and the initial position is given as 4. So like including using all of these information, our goal is to find the position function. So how do we work on this? So first of all, to work on this problem, we need to know the relationship between position function, velocity, and the acceleration. So if x of t here is given here as position, which we need to figure out later on, if that is the case, as we know, if we do the derivative of that, which is represented by x prime of t, or we can call it v of t, that will be our velocity, right? So v of t would be just the derivative of the position. But as we know, if we do the derivative of the velocity, that means v prime of t, or let's say the second derivative of the position function, which we represent by a of t, is actually acceleration. So that's how they are related with each other. If that is the case, it seems like to find the position function, we have given here the second order derivative of the position function as that. Everything as a function of t. So if that is the case, we can maybe use the repeated application of integration to solve this problem. Okay, so let's try this. So first of all, we have given the acceleration. So what we do over here is, if we have given the acceleration, that means the second order derivative of the position, we first get the first order derivative. So how do we get the first order derivative from the second order derivative? If possible, and find the entire derivative. And in this case, I think it's possible to do that because the velocity, if you want to figure out, which will be just the entire derivative of the acceleration, right, which is actually then means just do the entire derivative of 20 sine of 2t, and then don't forget to add an integration constant, but that's how we get the velocity function. So if that is the case, then what do we get here? This is equal to the entire derivative of 20 times a sine of 2t would be 20 is a constant, multiplied by entire derivative of sine of 2t would be, entire derivative of the sine is negative cosine, and because of the substitution rule, we'll have negative cosine of 2t divided by 2, right? So you need to remember a formula or know how to apply the substitution rule, that if we have, let's say, sine of at dt, being a as a constant, if that is the case, its entire derivative would be cosine of at multiplied by the reciprocal of a, right? So which is 1 over a. So this would be the entire derivative of sine of at. So I apply just that over here, and then we get this. So if that is the case, we get the velocity function as 20 divided by 2 would be 10. There is negative sign, so we get negative 10 cosine of 2t plus c is the velocity function, right? So that's what we get. But since we have given the initial velocity here, why don't we use that information here? It says that if you evaluate the velocity at 0, you should get -5. So okay, let's try that then. Evaluate the velocity at 0. So if you do that, then we get -10 cosine of 2 times 0 plus c. So 2 times 0 is 0. So that means we need to then evaluate -10 of cosine of 0 plus c. Cosine of 0 is 1. So we get -10 plus c. Right, so that's what we get. But what is given over here? The velocity at 0 has to be -5. So why don't we just substitute that over here? Then the velocity at 0 has to be -5. So this is equal to -10 plus c, right? So that's what we get. Then if that is the case, we can solve for c. So if you solve for c, we get c equal to 10 minus 5, right? And that will give you the value of the c is 5. So using that information, our velocity is supposed to be this. But we now know the particular constant, if we choose c equal to 5, it will also satisfy that initial condition. So if that is the case, we get the velocity function here as negative 10 cosine of 2t plus, instead of c, we'll substitute this value over here, so we get that. But our problem was actually to find the position function, so we just figured out the velocity here. So how do we get the position? A repeated application of the entire derivative. So that means here now we have the derivative, we need to get x, right? So how do you find x? From x prime, we'll do the entire derivative again. Okay then, so the required position function, which we represent by x of t, then can be figured out by just finding the entire derivative of velocity function. And we know the velocity function which satisfy that initial velocity 2 would be that. So we will integrate this with respect to t. So let's do the entire derivative. So negative 10 is a constant. Entire derivative of the cosine of 2t, like earlier, if we have entire derivative of cosine of a times t, its entire derivative would be entire derivative of the cosine would be sine. By the substitution rule, we get sine of at divided by a plus c. You could actually try to apply the substitution rule and then see if that works or not. Okay. I think I did apply the right formula, but wrote over here wrong. So entire derivative of the sine of at would be negative cosine of at over a, and entire derivative of cosine of at would be sine of at over a. Okay. All right. So alright, so we have here the negative 10, entire derivative of cosine of 2t would be sine of 2t divided by 2 by applying this formula, plus entire derivative of 5 would be 5t plus integration constant, which I forgot to write down over here. Let's do that. So this is what we get then. Okay, and this is equal to then negative 5 sine of 2t plus 5t plus d. So that's our position function without satisfying the initial position, which is given over here. X at 0 is 4, so we apply that. So that means now if we evaluate this at 0, right, so this will be equal to negative 5 times sine, replace t by 0 plus 5 times 0 plus d, but x at 0 is given as 4, so we substitute that here on the left hand side is equal to this is everything is 0 times negative 5, so we get negative 5 times sine 0, which is 0, right? So because of that, we can just say, okay, everything over here is 0. So negative 5 times 0 would be 0. So we can just write down that is 0 plus 5 times 0 is 0 plus d. Oh, easy to solve for d. We get d is just 4. Okay, then back to substitution here. Then we get x of t is equal to negative 5 sine of 2t plus 5t. And replacing d by 4, we get that as a required position function that satisfy all the given conditions. That means if you have the acceleration given as 20 times sine 2t, initial velocity is given as that, initial position is given that, then our position will be negative 5 sine 2t plus 5t plus 4.